In this video, we're going to solve this circuit using mesh current analysis. So what we have here on the left is a 90-volt battery. R1 is 9 ohms, R2 is 6 ohms, R3 is 8 ohms, and we have a 5 amp current source. So using mesh current analysis, calculate the current flowing through each resistor as well as the electric potentials at these points. Let's say this is the ground with an electric potential of 0 volts. What is the potential, let's say at point A, B, and C? So go ahead, feel free to pause the video, use mesh current analysis to solve this circuit. So what we need to do is identify the currents in each loop. Let's call this loop 1. And the current that flows through it, we're going to say is I1. The current that flows through loop 2 is I2. Now, the direction of these currents is not really important because we know in the second loop, there's a current flowing in this direction. So you can just make the directions of each current in each loop. You could just put them in a clockwise direction. And as long as you follow the pattern, it's going to work out. Now, you need to be familiar with Kirchhoff's voltage law, which basically states that the sum of the voltages around a closed loop circuit adds up to 0. Now, you also need to be familiar with the polarity signs. For instance, as you travel around a circuit, if you go from a negative value to a positive value, the electric potential is increasing. So this is a voltage rise. So you're going to use a positive V value. If you travel, let's say through an element, going from the positive sign to the negative sign, the electric potential is decreasing. So you need to use a negative V sign. So feel free to write that down in your notes somewhere because we're going to use that often. So let's say we're starting from this point and we're going to go around the first loop. As we travel through the battery, notice that we're going from the negative terminal to the positive terminal. So that's a voltage rise. So we're going to use positive V. Let's say VB for the voltage across the battery. Now going through this resistor, this is the positive side of the resistor. This is going to be the negative side. Current always flows from a high potential to a low potential. So that's going to be a voltage drop. Resistors tend to be associated with a voltage drop because they consume energy from a circuit, whereas battery tend to provide energy to the circuit, so typically they're associated with a voltage rise. Now this is going to be V1, the voltage across R1. And then as we travel through R2, that's going to be another voltage drop. Current is going to flow from VB, from a high potential to a low potential. Since VB is higher than 0 volts, this side should be positive. So we're going to use minus V2. Going through R2, it's another voltage drop. VB is higher than the ground value. So this is the equation that we have using Kirchhoff's voltage law. Now keep in mind that voltage is equal to current times resistance according to Ohm's law. Now we already know what VB is. VB is equal to 90. V1 is going to be I1 times R1. V2 is the current that flows through R2 times R2. Now the current that flows through R2, it's really the difference between I1 and I2. We have I1 going down in this direction, I2 going up in that direction. So the actual current that is flowing through resistor 2 is the difference between I1 and I2. So now let's simplify what we have. We don't know the value of I1, but we know that R1 is 9 ohms. So this is going to be 9 times I1. R2 is 8 ohms. Actually, I take that back. R2 is not 8 ohms, but it's 6 ohms. So let's correct that mistake. Now let's distribute the 6. So we have 90 minus 9 times I1 minus 6 times I1 plus 6 times I2. Our next step is to combine like terms. So negative 9 minus 6, that's going to be negative 15. I'm going to take the 90 and move it to the right side. It's positive on the left side, but it's going to be negative on the right side. Now I'm going to simplify this equation. I can divide everything by negative 3. So I'm going to have 5 I1 minus 2 I2 equal positive 30. Now, what is the value of I2? I2 is going in the clockwise direction, but we have a current of 5 amps going in the counterclockwise direction. So therefore, I2 is not 5, rather, it's negative 5 amps, because it's opposite to the actual direction of the current. So we can replace I2 with negative 5 amps. Negative 2 times negative 5, that's positive 10. And now let's subtract both sides by 10. So we have 5 times I1 is equal to 30 minus 10, which is 20. Dividing both sides by 5, we can see that I1 is going to be 20 divided by 5, which is 4 amps. So now that we have the current flowing in the first loop, and we also have the current flowing in the second loop, we have everything that we need to solve this circuit. So let me just clear out a few things. So we have a current of 4 amps flowing through resistor 1. And we have a current of 5 amps flowing through resistor 3. So 4 and 5 is going to add up to 9. So that's 9 amps of current is flowing through resistor 2. So now that we have the currents flowing in each resistor, we can now calculate the electric potential at points A, B, and C. To calculate it at point A, we really don't have to do much because the voltage of the battery is 90. So the positive terminal is going to be 90 volts higher than the negative terminal. And the potential anywhere along this line is 0. So this is the potential at A. Now what about the potential at B? What's the answer? V2 is equal to I2 times R2. That is, the voltage across resistor 2 is equal to the current flowing through it times resistor 2. Now, voltage is the electric potential difference between 2 points. In this case, the ground and VB. So V2 is going to be VB minus the ground, which is 0. I2 is 9 amps, R2 is 6 ohms. So the voltage, or the electric potential rather, at point B is 54 volts. Now what about at point C? How can we find the answer? Now the first thing we need to realize is that the current is going to flow from a high electric potential to a low electric potential. So the potential at point C is going to be higher than point B. So using this formula, V equals IR, we'll say V3 is equal to I3 times R3. The voltage across resistor 3 is going to be the difference between the potential at point C and the potential at point B, which is 54 volts. I3 is 5 amps, R3 is 8 ohms. 5 times 8 is 40, and if you add 54 to both sides, the potential at point C is going to be 94 volts. So that's how we can calculate the electric potential at every point in a circuit, as well as all of the currents flowing through each resistor in a circuit. Here's another example with 2 batteries and 5 resistors. Go ahead and calculate the current through each resistor as well as the electric potential at every point. So let's say the ground is given a value of 0. We already know that this point will have a potential of 130, and this point has to have a potential of 50 volts. Now, in the first loop, we're going to call this current I1. And in the second loop, that's going to be I2. And then I3 will be in the third loop. This is going to be the positive sign of resistor 1. This will be the negative sign. And this will be the positive sign of resistor 2. This will be the negative sign, since this is the ground, which has the lowest potential. So now let's analyze the first loop, started from this point. So as we go through the battery, that's a voltage rise. Through resistor 1, that's a voltage drop. And through resistor 2, that's a voltage drop. So this is going to be the voltage of the battery. That's a voltage rise, so we're going to give it a positive value. We have a voltage drop across R1, so that's going to be a negative value. And the voltage drop across R2, which is also negative. So that's the first equation that we have using Kirchhoff's voltage law. The voltage of the battery is 130. V1 is going to be I1 times R1. R1 is 10, so V1 is 10 times I1. V2 is going to be R2, which is 8, times the difference between I1 and I2. Now let's go ahead and distribute the 8. So this is going to be negative 10 I1 minus 8 I2. Minus 8 I1 plus 8 I2. And now let's combine these two terms. So negative 10 minus 8, that's negative 18. And then plus 8 I2. And let's take the 130, move it to the other side, where it's going to be negative 130. Now our next step is to divide everything by negative 2, just to simplify the equation. So negative 18 divided by negative 2, that's going to be positive 9. 8 divided by negative 2, that's negative 4. And negative 130 divided by negative 2 is positive 65. So we're going to save this equation for now. We'll use it later. Now let's focus on our second loop. So this is going to be positive, that's going to be negative across resistor 3. This is the positive terminal of resistor 4, and this is going to be the negative terminal of it. So starting from this point, as we go up through R2, that's going to be a voltage rise. So I'm going to have positive V2, and then as we go through resistor 3, that's a voltage drop, so that's going to be negative V3. And then going through resistor 4, that's also a voltage drop because we're going from positive to negative. So that's minus V4. So V2, we know it's going to be R2, which is 8, times the difference between I1 and I2. V3, that's I3 times R3. I2 times R3. I2 flows through R3 based on what we have here. So it's going to be 5 times I2. V4, the voltage across R4. We have a 2 ohm resistor, and it's going to be the difference between these two currents. So it's I2 minus I3. And this is going to equal 0. Now let's simplify. So we're going to have 8 I1 minus 8 I2 minus 5 I2. And then distributing the negative 2, this is going to be negative 2 I2 plus 2 I3, and that's going to equal 0. So we can combine those three values. So negative 8 minus 5, that's negative 13, minus 2, that's negative 15. So we have this formula, 8i1 minus 15i2 plus 2i3, all of that is going to equal 0. So we'll save that for later. Now let's focus on the third loop. We're going to make this side positive and this side negative. So going up through resistor 4, that is a voltage rise, going from negative to positive. So that's going to be positive V4. Going through resistor 5, that's a voltage drop, so negative V5. Now going through this battery, we're going from the positive side to the negative side. A positive value is higher than a negative value, so the potential is decreasing. So we're going to say this is negative 50. So in this case, this battery is being charged by the 130 volt battery, since current is going this way, if that is the correct direction of the current. If the current is going this way, then this battery is being discharged. Right now we don't know, but assuming if the current is going this way, then it's being charged up. Now if I3 is negative, that means that the current is going in this direction, which it could be. Now V4, we're going to replace it with the 2 ohm resistor times the difference between I2 and I3. V5 is going to be R5 times the current flowing through it, which is I3. So that's 5I3. Now let's distribute the 2. So this is going to be 2I2 minus 2I3 minus 5I3. And let's move the negative 50 to the other side. So now let's combine like terms. This is going to give us 2I2 minus 7I3, and that's going to equal 50. So now we have 3 equations, which is enough to find the values of the 3 unknown variables. So how can we solve this system of 3 equations? What do you think we need to do? What I would recommend doing is canceling I1 in the first 2 equations. That's going to give us an equation with I2 and I3, and then we'll combine that with equation 3. So what we're going to do is we're going to multiply this equation by 8. So 9 times 8, that's 72. 4 times 8 is 32. And then 65 times 8, that's going to be 520. Now, we're going to multiply the equation in red by negative 9. 8 times negative 9, that's going to give us negative 72. Negative 15 times negative 9, that's going to give us positive 135. And then 0 times negative 9 is 0. So adding these 2 equations, those values will cancel. And so we're going to have negative 32 plus 135. You know what? I forgot something. I forgot to multiply I3. That is 2I3 by negative 8. So that's going to be negative 18I3. And that's equal to 0. So now adding these 2, negative 32 plus 135, that's going to be 102 I2. I mean 103 rather. I'm making too many mistakes today. And then we're going to have minus 18 I3, and that's going to equal 520. Now let's combine this equation with this one here. So let's cancel I2. I'm going to multiply the equation in green by 103 and the equation in white by negative 2. So I will get negative 206 I2 and positive 206 I2. So I can cancel those variables. So let's start with this one. 2 times 103, that's going to be 206 I2. And then negative 7 times 103, that's going to be negative 721 times I3. And then 50 times 103, that's 5150. Now multiplying this equation by 2, I'm going to have negative 206 I2. Negative 18 times negative 2, that's going to be positive 36 I3. And then 520 times negative 2, that's going to be negative 1040. Now let's go ahead and add those two equations together. So we're going to have negative 721 I3 plus 36 I3, which is negative 685 I3. 5150 minus 1040, that's going to be 4110. Dividing both sides by negative 685, this will give us I3. So I3 is equal to negative 6 amps. So because I3 is negative, that means that we have a current flowing in this direction. So the current shouldn't be flowing from a negative value to a positive value. It always flows from a high potential to a low potential. So we need to reverse the signs of R5. So this should be the positive side, and this should be the negative side. Let's call this point A and point B. So the potential at point B should be less than 50 volts since current is flowing in that direction. Now let's go ahead and calculate the other currents. So let's use this equation before we multiply it by 103 to calculate I2. So it's 2 times I2 minus 7 times I3, and I3 is negative 6, and this is going to equal 50. Negative 7 times negative 6, that's positive 42. Subtracting both sides by 42, we'll have 50 minus 42, which is 8. Dividing both sides by 2, we can see that I2 is equal to 4 amps. So the current flowing through resistor 3, that's going to be 4 amps. So let me just put this here. I'm going to have to erase a few things just to have some extra space. So that's a 4 amp current right there. Now notice that we have 6 amps flowing through resistor 5, 4 amps flowing through resistor 3. So they will combine and form a 10 amp current flowing through resistor 4. Because 4 plus 6 will add up to 10. What just happened? Sometimes this computer acts up. Now let's calculate I1 using this equation. So this is going to be 9 times I1 minus 4 times I2, which is 4, and that's equal to 65. 4 times 4 is 16. So adding 16 to both sides, we'll have 65 plus 16, which is 81, and then dividing both sides by 9. 81 divided by 9 is 9. So that's the value of I1. It's 9 amps. So the current flowing through R1, that's going to be 9 amps. So what is the current flowing through R2? So let's draw a picture. We have 9 amps of current entering point A. 4 amps is leaving point A. that means that we have 5 amps that must be leaving as well. So there's a 5 amp current that is flowing through resistor 2. Now let's calculate the electric potential at point A and B. To find it at point A, we need to find the voltage across resistor 2, which is the current that flows through it, times R2. So the voltage across resistor 2 is the difference between the potential at A and the potential of the ground, which is 0. The current that flows through it is 5, and the resistance is 8. So 5 times 8 is 40. So that is the electric potential at point A. So I'm going to highlight this in green. Now, just for the sake of discussion, notice that across resistor 1, we see that the positive side is at a higher potential than the negative side. The negative side is at a potential of 40. The positive side is at a potential of 130, which is how it should be. Now, let's focus on calculating the potential at point B. The best way to do that is to find the voltage across resistor 4. So V4 is going to equal the current through it times R4. So V4 is going to be the potential at point B minus the ground potential. The current is 10 amps and the resistance is 2. 10 times 2 is 20. So this is 20 volts. Notice that the difference between these two potentials is 20, which is equal to I times R, 5 times 4. The difference between these two potentials is 30, which is equal to I times R, 6 times 5, which is 30. So everything should make sense if you did everything correctly. The voltage across each resistor should be the difference in the electric potential values, and that should equal the current times the resistance. So you can check that to make sure everything is correct. So that's basically it for this video. Hopefully this really helped you to be able to solve complex circuits like this one. Thanks again for watching.